Okay, I think this document cam setup is kind of readable. I'm going to try to write a little bit bigger on this. We're on page 2 with this thing now, so I'm just doing this page at a time, and I'll upload these in bite-sized pieces so that you can watch and try things out again. I'm working problems off from an old final exam, just giving you a connection to the kind of content that we covered all the way through this course, trying out some problems. My recommendation is to pause these when you can read the problem and kind of try it out yourself, and then see what we do, see if we end up with the same thing. And you know, any that you make mistakes on, that's a good learning opportunity, and if you're getting them right along with me, then that's a good confidence builder for this thing, and you get a chance to remember the stuff that we did. So I'm going to try to write big on these, and I think the text itself is kind of readable on this. We're on problem number 5 on this one, and it's also a solve the equation. Same instructions that we left off on. Solve the equation. This one's got a y, and it's just a one variable thing, and it's just a linear equation. There's nothing fancy in there. There's just y terms and number terms. This one is set up as a multiple choice, which is a little different. If you're a real calculation person, then you could figure this out by just plugging in each of these numbers, but you'd have to plug in the 960 in a few different places, and you'd have a lot of calculations to do. So I think it's actually easier to do out the algebra on this one, but we will hopefully end up with one of those numbers, right? That's nice. My thought process on equations is to get rid of the most complicated thing, and here that's these parentheses. This kind of looks like it came from mixture problem or something, but this is something I'm going to have to distribute the 0.15 there to these two terms. So I still have this one. 0.15 times 800, that comes out to 120. And that's minus 0.15y. And that's also supposed to be equal to 0.15y. So I got terms here, but I have like terms on the same side, so combining those would make sense here. I'm going to put those together. That's positive and a negative, so I get negative 0.10y plus 120 equals 0.15y. I have like terms here. Now they're on opposite sides though, so instead of combining, it's getting rid of one of these. I'm going to add 0.10y to both sides. That gets added together here, so that's 0.25y. So rewriting what I have left, this is gone. 120 equals 0.25y. And it's dividing by 0.25 or just multiplying by 4 here, because 0.25 times 4 is 1. So that gives me y equals 4 times this is 480. That is the solution to this thing. That's choice D on this multiple choice. That's the solution equation. Linear equations, we get one solution. Fancier equations, like we did toward the end of the course, you might get more than one by factoring or the quadratic formula. You might have to check them. This one you could check, but it should work. There's nothing fancy happened on that. This is solving for a specified variable there. So that's asking in this one to solve for b. So we just want to get the b by itself in this thing. If I have an equation with fractions, I like to get rid of the denominators first before I start rearranging everything else. So I might get rid of the 2 first, actually, by multiplying by 2. Just one term on each side. The 6 is the problem number. That's 2 times a, and that gets rid of the 2 right here. The point of multiplying by that was it gets rid of the denominator. This is all already multiplied, so it's not a distributing situation. It's just 1 times b times h. It's a associative situation, really. Now that I got rid of the fractions, solving for b just means get rid of whatever is with b, so that's dividing by h. And we get that expression right there, b is equal to 2 capital A over little h. And that's the expression that's equal to b there. That's the solution we're looking for there. A couple more on this page. While we're on linear equations, one of the fun things that we did was these great problems, applications that end up being linear equations like that involved distance, rate, time things, and involved percentage mixture problems and financial interest rates and stuff like that. This is one of the mixture problems. So different thought processes on setting this up. that we had. Finding the setup is really the deal with these things. But let me get an overview of the problem, and then we'll try to piece this together using some containers here. It is necessary to have a 40% antifreeze solution in the radiator of a certain car. The radiator now has 30 liters of 20% solution. How many liters of this should be drained and replaced with 100% antifreeze to get the desired strength? So we got weak stuff that's in there. We got to get rid of some of that and mix it with the pure stuff to bring that percentage up to 40%. And we want to know how much should be drained off and replaced. So we had some of these in on the lab, I think, back then. Draining off and replacing means the amount goes back down and then gets filled back up to the total. We're going to end up with 40% stuff. And you have 20% stuff and 100% stuff. This one that's in between is, of course, what you're going to end up with. Your mixture has to end up with there. So we know we're going to have 0.40 times something that we end up with. And we know we're starting with 0.20 times something and 100, which is 1, if you want 1.00 times something. The chart, if you like setting up the chart for these things, those would be the percentages, and we need to think about the amounts that go in here to make it into an equation. Now this says the radiator has 30 liters of the 20% solution, but I'm not keeping all 30 right here. That's the kind of deal with these drained off and replaced. Some of those 30 liters are going to get drained off and, you know, recycled. They're not going back in. So some of the weak stuff's going away. I'm starting with 30 liters and I'm taking some of it away, and I don't know how much. So X is the amount of liters that's drained off and replaced. And so what I have left is 30 minus X is the amount of the stuff that's in there now. And then I replace that with 100% antifreeze. So that's X liters that I'm using of the pure stuff that goes in there. And what I'll end up with, if you start with 30, you take away the X and you add X with it, you end up with 30. We're going to end up with a full system, 30 liters of the 40% stuff. So that's my equation. That's the setup on that. I'm going to do distributing right here to get rid of the parentheses on this, and then we'll see what we got to do to solve for X. So get rid of the parentheses first. This is the distributing part. 0.20 times 30 is 6. Minus 0.20x. This is really just 1 times x. And this is 12. And you multiply that out. So I got x terms, but they're on the same side. Do the combining right there, and then we'll subtract 6 from both sides to get rid of that. So a couple things going on at once, but this combines to 0.80x. And this subtracts to 6. So then I have to divide. Well, I got 0.80x equals 6. I got to divide by the 0.80. Be careful about which way around you do the division, but that should come out a little bigger than that. 6 divided by 0.80 is 7.5. There's some stuff you might use a calculator on, but I'm pretty sure that comes out to 7.5. So the answer to the question, now with the word problem, you always got to think you got the answer, the solution to your equation. But what's the answer to the question up here? How many liters of this should be drained and replaced with this to get the desired strength? So how many liters were drained and replaced? Well, that is the X value. That is the liters of it. So my answer would be 7.5 liters. Or I should have your units on that in a word problem. That's kind of extra things that we got to think about when we're in an application problem. Once you get your number from doing the algebra and the calculations, you got to think back, what do I do with that number to actually answer the question they were asking, and make sure you're given the right value at the end and the right units. This one doesn't have a physical situation around it or anything, it's just algebraic, but they're not actually asking you to solve it. Here, watch your instructions. It says decide whether the following is an expression or an equation. Is just kind of the multiple choice right here. So which one is it? Well, this has an equal sign in it. It's a bunch of stuff with z, and then it's supposed to equal 12. That's only going to be true for certain values of z. But anyway, it's an equation. It's either true or false based on whether it equals 12. That's an equation and not an expression. They're not actually asking you to solve it. They're just asking which one that is. So that's another page on that. I'll have these up. And we go on to page 3 next.